How we doing, folks? Let me get my other screen up. Hmm, that's interesting. Okay, there we go. Okay, there we go. Alrighty. Alright, who's in the room? Who's in the room? Alright, ladies and gentlemen, how you doing? This is another live stream event by STEMwithKino.com. If you are preparing for the FAA computer test exam for like pilots, private pilot through airline transport pilot, or if you're preparing for a military aptitude test, then this is the place that you want to be every week. Not really much I wanted to add after that. So basically, if you're preparing for the test, maybe you've taken the test, maybe you didn't pass it, maybe you need to raise your math scores or something like that. This is definitely the place you want to be. The way that you get the most out of this live stream is if you just merely just go through your book, put a check mark in the book, and then, just present the problem to the room here every Friday night. 9 to 11 we're here normally, unless, something uneventful happens. So there's the email that you would present your questions to, KIENOTHOMAS@gmail.com. And I'm going to the Alright, just checking my email. Alright, let's go to the email. And that first email I have is asking me the difference between a parallel circuit and a series circuit. I'm sorry, guys, I'm yawning. Long day. Alright, so the difference between a parallel and a series circuit. In a series circuit, there is only one path for electricity to flow. I've addressed this before. So there's like one circular path to flow in a series circuit. In a parallel circuit, there's more than one path for electricity to flow. So there's actually two ladders or two branches that exist, and there's more than one path for electricity to flow. So while the flow would pretty much go in a circle in the series, this actually has two paths for electricity to flow. So I hope that answered your question. Moving right along. Okay, we covered this a lot. This is a system of equations question. And basically, where's my little makeshift eraser? Basically, person is sent a question: x plus 6y equals 15. And 3x minus 12y is 18. Okay, what we have here are two linear equations, and what we're going to do is we're going to solve these two linear equations simultaneously. All right, so what I will have to do is manipulate one of the equations. So what I will do is I will manipulate, let's see what's easier. I can do this a couple ways. I can multiply this equation by -3 so that the x's cancel out when I add downward. Or I can just multiply this by 2 so this becomes a positive 12y and it'll cancel out with the 12. Because ultimately what we're going to do is we're going to vertically add. So we can manipulate the equation in such a way that when we vertically add, it cancels either the x values out or the y values out. All right. So I think the best thing to do is I'm going to go with multiplying equation 1 by 2. I'll just put E1 on the side just for like a little note. All right. So if this is multiplied by 2, this will become 2x. This will become positive 12y, and this will become 30. All right, so now we're going to forget about equation 1 for a minute, and we're going to vertically add. So it's actually going to be the manipulated equation and equation number 2. So 2 plus 3 is 5x. 12y and negative 12y are going to cancel out. And 30 plus 18 is 48. And let me make sure it is the original question. 49. Because this being 48 is going to make the question a little crazy. But it's okay. We'll get to the bottom of this. Alright, so x is going to be 9 point something. 48, 5, and 9, 45, 30, 9.6. So x is going to be equal to 9.6. So what we're going to do is we're going to plug this in for the x value. We could do it here or we could do it there, but it must be tested. So what's going to happen is we're going to have 9.6, which is the x, plus 6y is equal to, and let's make sure that we're getting all of this. Because sometimes I know my camera's a little tilted. Okay, we're getting everything. Okay, and basically, what was 6y and then 15? So we've isolated y. We found out what x is, and we've isolated y. All right, now 9.6 is going to go to the other side and become negative. And if we do that, it's going to be what, 5.4? So 6y is equal to 5.4. The 9.6 is going to jump across and be subtracted from 15. We'll have 5.4 remaining. So y is actually going to be 0.9. I can see it because 6 times 9 is 54, and 0.9 will be 5.4. So our x value is, our x value is 9.6, and our y value is 0.9. All right. Good question. Really good question. All right. And as you guys come in the room, just tell me what location you're from and what test you're preparing for. Please. All right. This is an interesting one. I've seen this one before. Whenever we see right triangles, the first thing that we have to ask ourselves is this a 3, 4, 5 triangle? And I cannot beat that in your heads enough. You know, is this a 3, 4, 5 triangle? And we have a circle. This is point O. And what the question is stating is that we have point A, point B, and they said that this length is 4, and this length is 4. And we have a line coming down, and this point is echo, or E. So they're saying that O to A is 4, and this length, alpha to Bravo, is 4 units long. And they want to know the distance of O to E. So O, line OE, is what we're looking for. So the first thing that we have to ask ourselves is this a 3, 4, 5 triangle? And it is not, because the hypotenuse would be 5. We do have a right triangle, but the hypotenuse is not 5, it is 4. So what we're going to have to do is we're going to have to use the Pythagorean theorem, which is a squared plus b squared equals c squared. So that's our hypotenuse. This is 4, so this is kind of like the midpoint. It is the midpoint, so this side is 2. So we'll say A is the side we're looking for, plus 2 squared, equals 4 squared. A squared equals 4. A squared plus, I don't know what the heck's wrong with me tonight. 2 squared equals 16, because 4 times 4 is 16. 4 will go to the other side. A squared is equal to 12. But we're not solving for a squared, we're solving for a. So the exponent comes off the a and the square root goes over the 12. Now we have we have root 12. None of the answers are root 12. Actually, what they've done is they've simplified this radical. So I see square root of 4 and the square root of 3 are equal to the square root of 12, and then the 4 reduces, and this distance, O to E, is 2 root 3. Alright, we've seen that before though, guys. So, but I know how frustrating this could be when you don't understand it, and so that's the only reason why I jumped into it. Alright, I am. Okay, alright, this question is an aviation question. It is asking, when are the four forces of flight in equilibrium? Well, basically there's four forces of flight that we primarily talk about in airplanes. So let's draw our airplane. Alright, so this is our airplane. And we have four forces. We have a lift vector, a drag vector, and I'm trying to make these as even as possible. Alright, so there are four forces of flight, and the question is asking us, when are the four forces in balance? The four forces are in balance in level, unaccelerated flight. Only. Level, two conditions, and the second one is unaccelerated. So condition one has to be level. What that means is that we're not getting more lift than weight. The forces are balancing each other out, so I'm not climbing and I'm not descending. The second condition is unaccelerated flight, so thrust and drag are balanced out, which means thrust is counteracting drag perfectly and zeroing it out. So you have one force going this way, one force going that way, and it's of the same magnitude. So the forces are the same. The forces are the same, and the net force is actually zero. So in order for an aircraft to be in level unaccelerated flight, you have to satisfy two conditions. One, level unaccelerated flight. So that means the pilot is not increasing speed or decreasing speed. It's just at a constant speed, and it is not climbing or descending. It's just in level unaccelerated flight. And that's when the four forces of flight are in equilibrium. So I hope that answered the question. Right. Okay. We had a question today, and I didn't get into a disagreement or anything, but I guess we looked at the question differently. And Mario, you were right. You were right. All right. So what we have is we have two different situations. Well, that's not how the question was put, but now this is actually touching as well. So we can pull this object two ways. Let's say it's on a table, and this is a table, but this is kind of cut out. All right. So we can pull this object two ways. We can either pull it horizontally like this. Let's make our little stick man. Or we can pull it like this. Bigger stick man. And the question was asking was which situation requires less force to pull the object. Now, based on a little bit of research I did, I was under the impression that this was easier and this was harder. No, this was easier and this was harder. That was what I was under impression of. But it turns out that this is easier and this is actually harder. So I was like under the impression because this had more surface contact. But when we pull up like this, it's kind of going to raise a little bit. All right. So I thought that this was harder, this was easier, and this was harder. No, I'm sorry. This was easier and this was harder is what I thought. But actually this, I'm going to get this right. This is harder and this is easier. All right. So I'll do this. I'll put what I thought, me, and then I'll put what Mario thought. All right. How about that? All right. So I was under the impression that this was harder. Mario I'm jacking this up. Easier. Yeah, okay. I was under the impression that this was harder. Mario was under the impression that this was harder to pull. So, if we were going to pull it and use the least amount of effort, this will be the correct way to pull it. Alright. But I thought this was harder because of the surface contact, and I have a diagram. I thought that this situation was harder, but this situation was harder. So you OAR people and you ASTB people, you're going to be presented with questions like this. Well, they'll give you pictures and I'll ask you, alright, which one is easier to pull? This guy's easier to pull. The one that's pulling in the horizontal plane. Alright. So, I hope that didn't confuse you. If it did, just pause, go back a little bit. Alright. Send me with those questions, folks. Keep them coming. There was another cool question for you SIF guys, the mechanical comprehension guys. And it was like really kind of it was a tough, if you didn't watch the question, you could answer it wrong. All right, I'll talk about that one next, and then I'll go to the next email question. Okay, so we have a person here on the bottom. All right. And it says that they throw an object in the air. And then what goes up must come down, right? So let's say this is the halfway point. All right. So they said they threw the object in the air with a force of 100 foot-pounds of, I put EP, okay, with kinetic energy. All right. So you have to understand what energy is. Energy is if we put here, I'll put E, which means energy total, is equal to EKE, kinetic energy, plus E, potential energy. And you must understand that whatever the total energy is, it's never going to go away. It's either going to be high here and low here, or low here or high here, or they're going to be balanced. All right. So the question was worded like, okay, this person throws the object up in the air with 100 foot-pounds of kinetic energy. All right. So what does that mean? That means at this point, point 1, and we'll say this is point 2, and then we'll consider point 3. So at point 1, kinetic energy, I'll just put KE because we know we're talking about energy, is 100 foot-pounds. So this is the starting point, or the initial point, 0, all right, altitude, all right? So this tells me that the potential energy is 0 foot-pounds. All right. Now what they do is they ask you, what is going to be the potential energy, or the amount of kinetic energy halfway up. So it's on its way up, halfway point is point 2, and the top is 3. So at the halfway point, what is building up? We're actually losing kinetic energy. And like I said, the total energy is still going to stay at 100 foot-pounds. As it goes to the halfway point, what's going to happen is we're going to have 50 KE and 50 PE. But notice, we're still at 100. We're at 100 as far as total energy is concerned down here. We just had 100 foot-pounds of kinetic energy and 0 potential energy. But then when we get to the halfway point, what we have is 50 foot-pounds of kinetic energy and then 50 foot-pounds of potential energy. When we get to the top, and it can't fight gravity anymore, then what happens is we have 0 kinetic energy and 100 potential energy at that point in time. All right. So I thought that was a really, really good question, and the person understood it and got it. All right. So that was like, I even had to look at that question. And that's why I like doing this, because I see so many questions, and it just makes me better. And so, you know, when you can mentally wrap your head around this stuff and actually get it, that's like a beautiful thing. But, you know, he went in and he got it, and it was like pretty cool. I was pretty impressed, because not a lot of people can look at these diagrams and then just figure them out on their own. I mean, I've been tutoring him for a while, so. You know, he is at a certain level where he's starting to really slow down and observe. You know, when you get lost in word problems, everything is line by line and diagram. Fortunately, I believe this one had a diagram. Yeah, so when we initially throw the object in air, we had 100 foot-pounds of kinetic energy. Potential energy was 0. At the halfway point, kinetic energy is falling from 100 to 50, and the potential energy is building up and actually increasing. The higher we go up to the top, they slowly change position, but they still equal 100 at the end of the day. We have 100 total energy in foot-pounds here, 100 total in foot-pounds of energy here, and 100 total foot-pounds of energy here. So that was like, you know, to see him just go in and like kill that was good. Shout out to Reed. Strong improvements. You know, all my people are doing well, but, you know, when I notice, like, when they first came to me and they're like, oh man, I hate math, I can't do this, I can't do that. And then they get to the point where it's just like, they're just like, boom, 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 boom. I throw them a question, boom, they throw it right back at me. Like, what? What? I got it. This is my answer. You know what I'm saying? So it's just a beautiful thing, man, you know, to watch someone that really doesn't know much about math or problem solving and then turn them into, like, I guess you could call them question killers. Yeah. But I tell them, like, they're getting Kino vision because they can see it. A lot of times I can see a lot of questions and I solve them in like seconds. But, you know, that's neither here nor there. Moving right along. Alright. And welcome, Alonzo. I see your comment. Option 1, you thought option 1 was easier. I'm not sure what that means, but just type that in if you're talking about this question. It might be the question before, because I pretty much got really, really engulfed in this to really get the point across. And I realized there's a delay, so I'll check back. All right. Oh, the previous question, all right. Yeah, I thought the same thing too, because you would actually be raising it and stuff, but we'll talk about that in the Google Hangout. Oh, I got questions. Excuse me. Okay. This was another really cool question. I was able to demonstrate actually 2 different areas of pressure. We had a question where you had the bottom of the surface of water. So I'm going to write the bottom. This is the surface of the water. Let me put some nice little sea plants in there, whatever, you know, plant eating fish and stuff, and maybe put a little rock under there or something. All right. Now what I'm also going to do is I'm going to draw a line. And then I'm going to, this is the ocean, and that's land. Now these are 2 different situations that I'm separating. I'm showing you the bottom of an ocean floor, or let's say ocean floor. And then here I will put sea level. Until you get to the land part, but it's sea level. Okay, so this will be the top of the surface of the water. And on this side of the coin, this would be, let's say, 40,000 feet in altitude. The reason why I'm doing this is I'm trying to show you how water and air, hydrodynamics and aerodynamics, kind of act very similar. So I have an ocean floor here, and then I have sea level here. Now, is everybody clear of what I have set up so far? Because this is really, really important, and I don't want to get people lost. So just type in a clear. So I have an ocean floor on one page, or one half of a diagram, and then I'm kind of showing you the similarity between what happens at sea level. Okay. So here's the thing. You had 2 containers. And I'll try to, under the surface of the water. Okay. And it is, what the question said is they took one of the containers and they raised it. So this is position 1. and position 2 is here. All right. And this doesn't move at all. So the question was asking us, we move this block or vacuum from position 1 to position 2. All right. And they said, okay, will it experience more water pressure, less water pressure, or the same water pressure as this guy? And it is less water pressure. Because the deeper you go, the more water you have on top of you. And I'll make big vectors for here. Boom. So the water pressure is really, really exerting itself. Because all the water pressure above here is exerting itself on the walls of this container. Now, as we raise this up a little bit, it is a shorter distance, longer distance. So it has less water pressure from the top above exerting. So I'll make it very smaller arrows to demonstrate the pressure. So initially we have two boxes in the same place, and they're experiencing the stronger water pressure. But when we take this and we move it up to the second position, position 2, then you notice that the arrows are smaller, so less water pressure is being exerted on it. Now, why the hell did I put this next to sea level? It's because the atmosphere does the same thing. All right. When we are at sea level, and if we took a block of air, we trapped it, it would weigh 14.7 psi, or pounds per square inch. All right. And if we went to 30,000 feet, and this is not an exact number, I'm just saying 7 psi. The thing to understand is that the atmospheric pressure is getting weakened. And in the same similar scenario, when we leave the ocean floor and we get closer to the surface of the top of the water, we experience less pressure. So high pressure at the surface of that ocean floor or sea level, and as we get up and higher, we experience less pressure being exerted on us. This is why, people have problems breathing like high altitudes. At lower altitudes, and the air just basically comes in when your diaphragm expands and the lungs say, okay, come on in, air, or oxygen. And speaking of oxygen, we might as well talk about the atmospheric composition. But does everybody understand that? Here, the two boxes were experiencing greater water pressure, but when we raised this one, it was experiencing lesser water pressure. In this case, we're at sea level, we get in a plane, we take off, we go to about 30,000 feet. Down here at sea level is 14 psi. Up here, it is 7 psi. All right. And this is the reason why when we get depressurization in airplanes, when you see the movies and somebody fires a gun and then the window breaks, and then all of a sudden, everything's trying to suck, that opening is trying to suck everybody out the airplane. Now they do over-exaggerate it a little bit, but they have to. It's the movies. They have to make it dramatic. But this is the reason for that is because we couldn't take humans to that altitude without bringing our own atmosphere. Now, what do I mean by that, our own atmosphere? When you fly commercially, these are seats. These are seats, and I'll just make the front of the aircraft. All right. When you're flying, everything in here is actually pressurized, which means it is in its own pressure chamber. This is what we call pressurization. So we're bringing atmospheric pressure in this tube up with us to simulate maybe 8,000 feet. We'll just say 8,000 feet. Because at 8,000 feet, humans can still function well at 8,000 feet. There's enough pressurized oxygen to make that happen. So what happens when, on the movies, when a window's broken or something like that, if we're at 30,000 feet, at an altitude of 30,000 feet, and we crack this pressure chamber, all right, then what happens is the inside tends to equalize with the outside. And that's why everything is sucked out, because we brought a lower altitude up to this level. And once, if there's any cracks or anything like that, then it's going to equalize. And that's why you get the suction, because you have low pressure on the outside, high pressure on the inside of this chamber. And the high pressure has got to equalize or balance out with the higher pressure once a crack, or like in the movies, somebody opened the door or something like that on the airplane while it was in flight. So that was an interesting question, and just some things that you need to be aware of. And then I was going to actually talk about the atmospheric composition before I got into like depressurization. But do you know that most of the air that you're breathing is probably only about maybe 21% oxygen? No, let me not say that. Let me stick to the atmosphere and talk about atmospheric composition, which means if we took the entire composition of the atmosphere, all right, it is actually, one would think that it was all oxygen, but it is not. It's about 78% nitrogen and only 21% oxygen. And then you have other trace gases, carbon dioxide, argon, helium, and neon. All right. Very good, Leon. Very good, Leon. Leon, congratulations. He got a 53, a 665. Now, are you going Coast Guard, Marine Corps, or Navy? Great. The Navy is really short on pilots, if that's what you're looking to do. And since you got a 53 and you took a Navy, you didn't just take the OAR, you actually took the full ASTB. So either you're trying to become a naval flight officer or a pilot. And just so you know, I do have an API preparation course. I'm just saying, just putting it out there. I'd like to talk to you, have a conversation with you. All right. That is me on Skype if you're on Skype. Or if you'd like to come to the Google Hangout after this in about 15 or actually 14 minutes. And unfortunately, only my paying subscribers will be able to attend. I hope you have a Gmail account, because I guess you can send your Gmail account to my Gmail so I can send you the link for the Google Hangout. But see, this is the thing, you know, people that tutor with me, you know, are privy to, you know, like information with somebody experienced. So, you know, yeah. If you can make it to the Google Hangout, I'm interested in speaking with you. And if you can't, I'd like to talk with you on Skype, and that's my tag. So just towards, like in 10 minutes, just hit me up with an email saying, hey, just Google Hangout in the subject. And then I'll just send you the link once I get the Google Hangout set up. But those are really, really good numbers. You definitely want to break 50. And so what did now you put pilot NFO. I mean, which one do you want to do? Do you want to be a pilot, or do you want to be a naval flight officer? my videos helped you a lot. That's why I do them. You know, that's why I do what I do, and that's why I try to be here every week. Sometimes it's tough. You know, I have things going on like last week. It just, life happened, and, you know, I just had to tend to some stuff. And I apologize because I should have did like a little 10-second video saying, hey guys, like, look. So I will do that in the future. All right, NFO is your secondary. Oh, they need pilots. They're going to be like, hey, look, I want you to fly. You know, depending on your physical and all that and everything. I don't know if you physical already or not. If you've done your Flight 1 physical. But, yeah, congratulations to Leon. Leon has been coming to the sessions here almost every week and presenting questions and watching questions being worked out. There's a lot of problem solving being done here on the channel. And the thing is the only way you're going to be good at problem solving is by solving problems. It's the only way you're going to get good. There's no easy way out. I mean, I teach time-shaving techniques, so that makes it a little bit easier, but there's no easy way out. You have to do the work, folks. You know? And, you know, just buying a book and just thinking like that book is going to have all the answers. That's kind of crazy a little bit. But I know how they sell themselves and market themselves. Hey, buy our book. Our book is the shit. Pass your AFOQT, pass your ASTB, pass your OAR, your SIF, your ASVAB. You know, I try, brother. I've been doing math a long time. And unlike with me in a lot of situations is the math that I executed, my life depended on it, and the lives of my crew or passengers or whatever depended on it. So not only did I had to be good at math, you know, in my line of work. So yeah, in 10 minutes, I gotta check in just see if there's any more questions. Well, there were more questions, but I want to see if I could squeeze another one in real quick because it's pretty much 9:50, and I will be setting up. So, Leon, go ahead and send me that email, and hopefully, I hope it's a Gmail account because it's a Google Hangout, and they just tend to not give you grief. Because I think if you're not if you don't have a Gmail account, for instance, if I'm sending it to a Hotmail email account, then it's like they have this thing you got to download and everything because, you know, it's like, hey, this isn't our Gmail. You're not a part of us. And, you know, they take you. So if you do have a Gmail account, that would be great. I will post my email. And Alonzo, although you're not taking a full ASTB, he still has information relevant to your testing because the OAR is actually the first part of the ASTB. So that's something you definitely want to be in the mix on. All right, 2526. What is the next number in the sequence? All right. Hopefully everybody was clear on that, but all right. So he's giving us a 2, a 5, a 26, and ... What is the next number in the sequence? All right. What are my options? It was multiple choice. Give me some options. It's not a arithmetic sequence, I don't believe. All right. 32, 64, and 678. Hey, Maria. Okay, and folks, don't be afraid to jump in. All right. What is the next number in this sequence? I'm looking at 2 to 5. All right. There's 3. If we added 3, and we would have to add 21 in order to get to 26. And as far as a geometric sequence, we jump 3, 7. If I had to take a stab, I think 678 is way too far out. Because we have a 3, then a 21, and then now 26. 32 is too close. So I would go with 64. Because I can't really see the arithmetic or the geometric sequence. But what I do know is the space between numbers. We have 3 between 2 and 5, and then 21 between here. So, to me, 32 is not logical. It would be further away, I would think. So 64 is kind of in the middle. And then 678 is like way, way, way. It's 678, is it? All right, 2 times 2 is 4, plus 1 is 5. 2 times 2 is 4, plus 1. 2 times 2 times 1. No, it's 4, plus 1 is 5. Okay, I can see that. All right, so hold on. What they're saying is 2 times 2 plus 1. So 4 plus 1 is 5. And then we say 2 times 2. So what they've done is, so you multiply by 2 and then add 1. All right, is that what's going on? So 2 multiply by 2 and then plus 1 add 1. So 2 times 2 is 4 plus 1 is 5. Now let's see, 5 times 2. See, that doesn't work. It has to work as a sequence. If it's arithmetic, or that's geometric, but still, 5 times 2 plus 1, 5 times 2. Yeah, that's maybe you can explain it to me. When you are squaring each number and adding 1. All right, so 2 squared is 4. Okay, all right, I see it now. So 2 squared is 4 plus 1, 5. 5 squared is 25 plus 1 is 26. So this will be 26 squared plus 1 to get us 678. Okay, so, yeah. That's good. That's good. Did you see that on your exam? Or a question like that? Okay. That's good. So everybody here has seen it. Maria, I did see you in the room. You can come to the Google Hangout. Because we have a special guest today. Well, all of you are special, but we have a debrief that we're going to do in a Google Hangout. So that debrief is not for everybody. So, Maria, make sure that you send me an email. And I'm pretty sure that Alonzo is coming. It's 9:57, and I'm actually setting up the live stream because I have 2 computers. I'm like, wow. I'm like, oh, moving up in the world. I can actually set up the live stream the Google Hangout as we speak. How cool is that? But while I set up the live stream, and Leon, I hope you have a Gmail account because this is really always an honor to talk to someone that has had eyes on this exam, because it's unfair. It's tough and it's unfair. And I don't even know how long you've been watching my videos, but if you got a 53, I think you've been watching them for a while. Yeah, let me talk myself up. You had to be watching them for a while because you got such a great score. But what am I doing here? All right, okay. No, I'm just kidding. I'm not that way. Yeah, Maria, you should have sent it to my email, not posted out there for the public. I mean, I don't think there's any weirdos here, but you never know. Okay. So actually, okay. So just to recap, if you guys are preparing for the ASVAB, ASTB, OAR, AFOQT, I know I'm missing one. AFOQT, ASTB, OAR, ASVAB, or any FAA pilot computer test examination, this is the place you need to be. It's free to come to the live stream. You can send me your questions. I'll help you figure them out. I've taken all the pilot exams, all of them, from private pilot all the way up to airline transport pilot, all the ground school ratings and all the instructor ratings. There's literally no pilot rating that I have not obtained pertaining to pilots as far as the FAA, as far as the Federal Aviation Administration goes. So I am an expert, and you shouldn't be struggling with the test if you're having problems. I'm here every week, and the live stream is free. So again, guys, send me your emails. Leon, especially you. So I am Keno Thomas with STEMwithKeno.com, and I thank you guys for taking time out to come to my live stream. Have a great day. And Leon, did you get that email sent over to me, buddy? I gotta check with him. They go, yeah, I'm gonna send you an email, man, and they don't send an email, man. I'm not saying he did that, but people, they talk sometimes. But no, I trust you. I'm pretty sure, but I just want to just verify because I'm about to start sending those links out. And this is pretty cool, though, me being able to set up my my live stream as we talk. And please hit the like button as well, guys, if you guys like the stream or if you disliked it. Either way. Alrighty. Alright, Leon, yours is sent. Alonzo's is away. And gotta figure out how. Alright, I'll copy that. I'll just have to type yours in by hand for you. right, guys. Where am I typing yours in now? Oh, okay, Kiana. I didn't even know you were in the room, hon. I didn't even know you were in the room. So y'all gotta holler. Y'all gotta let me know y'all in the room. Y'all can't just be All right, Maria. Let me see here. Oh, I'm always watching. You're like Big Brother. Got your black shades and the suit on. We're always watching. It's like, good. You learn something.
Leon in the room.
All right. I'm still setting us up here.
Okay.
Kiana, I'm sending yours through our Skype connection. Maria, I'm trying to do the same with you. And guys, on the live stream, this is the point where I give you the finger. Pow.